Welcome to today's live stream. Today what we're going to do is going to analyze some Wireshark packet captures. So we're going to take a look at some packet captures that are been previously captured here. And what you can do is you can find these on Wireshark's website. They have a whole archive of packet captures. If you want practice with Wireshark, it's a great way to look through these packet captures and identify certain attacks. So let me just show you what this site looks like first, and we'll go ahead and get started here. If you have any questions, please leave a chat. Be happy to answer your questions. This is going to be an open study session, so if you have anything, be happy to answer any questions you might have. Okay, so this is the Wireshark website here. And what we have are the Wireshark sample captures. So this is from the Wireshark wiki. And you just go Wireshark wiki and then you go sample captures. Takes you to the sample captures page. Now the sample captures have multiple categories here. There's a table of contents. You can look at Bluetooth, for example. We can look at SMB vulnerabilities. All these different vulnerabilities that we can find packet captures for in Wireshark. So I've downloaded a couple of these, and I think a couple that I think would be useful to look at. One of them was a teardrop attack. Viruses and worms has its own category, so that's where I think a lot of these would be really good to look at. Trying to see examples of remote access, different types of vulnerabilities, different types of attacks, different vulnerabilities being exploited. So in my folder here, I have a couple. I want to take a look at the teardrop attack first. And if we take a look here, we see, maybe find teardrop. It says packets 8 and 9 show the overlapping IP fragments in a teardrop attack. So let's take a look at that packet capture and see if we can discover that on our own. So let's open Wireshark first. And then which I have open here, and we'll open that packet capture. I think you can just drag and drop in here, honestly. Yeah. All right, great. So we have this teardrop capture here. So we can analyze this is a very simple one. So let's see. We have different protocols here, different lengths. And it looks like source and the destination, we have a Cisco device. And as we go through, packets 7 and 8 are shown to overlap. And let's see how is that what they were explaining to us here? Let's double check. 8 and 9 overlapping IP fragments in a teardrop attack. Okay, so right here, we have an IPv4 packet, and then we have a UDP packet, both sent to from the same source to the same destination. And this one's fragmented. And then this one has a UDP segment to it. And then all of a sudden we have, so I think this is showing correctly what we're trying to look for. Teardrop attack, of course, is denial of service attack. It's a technique of a denial of service attack where you send a fragmented packet. You send a packet that's not complete, and we do see that in packet 8. So the idea is the fragmented packet essentially causes the server to be unable to reassemble the packet properly. Okay, and right here it says, right here, reassembled in 9. So here's our packet. $36 bytes. Okay, data. This is our data right here, but this isn't the standard length for a packet, I think. So this is what we should expect to see, something like this. And then this is what we see in this packet. So you see this DNS packet, or this DNS packet, as opposed to this IPv4 packet. We don't even reach a standard length. So it's a portion of a packet. And that could happen sometimes normally, but if you do it in a specific way, then you can create a condition where essentially the server tries to reassemble the packet but is unable to. Usually this more affects older systems. And it's really exploiting a flaw in the reassembly process of the server. So we do see evidence of that in packets 8 and 9. Here, 8 being the fragmented, and then 9, it's reassembled. Let's compare this. We have 0039CF ending in E524. 0039CFD9 3E5. So it's reassembled, but it's reassembled incorrectly. And now we have a bad UDP length. So basically the server tried to assemble the packet in line 9 here, but it didn't do that correctly. And then now we have different ARP requests here as a result. So this is just a very short example. Let's go ahead and take another look at a different packet capture here. And the great thing is you can save these packet captures. If you can either use this for your own network, or you can use this to analyze and practice with previously captured packets. So any packets that you capture, any sessions you capture, you can save. We can save this as and name this our own name or whatever. If we did this capture ourselves, we'd be able to save that and then analyze it later. So that can be very helpful. All right, let's take a look at another one here. Let's take a look at the Slammer worm. I think I downloaded this one. Okay. Okay, so this is just one packet. So this is an example of what the Slammer worm looks like. DCERP. So this is the worm itself. So this is exactly what the worm would look like. So if you wanted to feed this to one of your security devices to help it understand, though most vendors would have this already integrated into their machines. But this is a good example if you need to train your personnel on if you're susceptible to that Slammer worm. That can be pretty helpful to see. And Slammer worm is, I believe, an SQL vulnerability. Let's see if we can find some information on it. It's a pretty old worm, I think. Yeah, this is very old. So Slammer worm apparently was developed in 2003. also known as Sapphire or Hellkern. And it was an SQL worm affected Microsoft SQL servers. So a classic example of a worm here. And a worm, we know, it's a type of virus that's going to propagate itself on a network. So once it infects one machine, it's going to try and replicate itself by convincing that machine to transmit the worm to another device on the network. So it'll quickly spread throughout a network because each device it infects, it'll try and force that device to send the worm to another device on the same network. Like I Love You worm was a very common example that would do that process through Microsoft Outlook contacts. There's many different ways a worm can accomplish that. And this Slammer protocol, let's see how that's it's using RPC. So it's using a Windows protocol here to try and help it get propagated throughout the network. Now, just looking at this information, not knowing too much about Slammer, or not remembering too much about Slammer, we see .dll here. Okay, so I wonder if this is, and you see how it's using remote procedure call or RPC. DLL makes me think that this is a worm that compromises or at least infects some sort of dynamic link library, and let's see if that's the case here. And I'm looking if we can find anything like that. Oh, I see. So it's so old that would infect the file type .dll on the SQL server. So it's also known as Hellkern. And what it does, it infects either kernel 32 DLL or WS2 underscore 32 DLL. So those are different files that would be on the SQL server and in earlier deployments. This is an early 2000, this is affecting Windows Server 2000. So earlier Windows operating systems had the Windows system files a little more exposed than modern operating systems. So this would be an effective worm because this would basically affect those files in the system folder in the server. So that makes sense. That's why we're seeing that DLL here on the packet itself. So that's pretty interesting. So something we're learning here just by analyzing the packet capture that we might otherwise not have known. So that's pretty good. So just by analyzing this packet capture, we're learning a little bit about this ancient worm, I guess. It'd be ancient by today's standards. So that's good. Let's try another one here. And just going through these examples really shows you it's nice to learn these concepts in theory, but really working with a packet capture like this, seeing a live example can be very helpful. All right, let's see. Now we don't have, not all of these are just viruses. We have packet captures for all sorts of protocols. So we can take a look at different protocols families. And let's look at SNMP. Let's take a look at those. And then we have Kerberos. And we can take a look at Kerberos here. SSL with decryption keys. I mean, there's lots here if you want to take a look here. I want to find something a little more recent. Let's take a look at those two, and I want to take a look at here, IP security. That'd be useful. With Internet Key Exchange. Dissection of encrypted and UDP encapsulated Internet Key Exchange version 2 and encapsulating security protocol messages, ESP. Let's take a look at that one. Okay, so this one says, and it's going to give you some descriptions here. A VPN client behind a NAT device connects 3 times a VPN using IKE v2. User sends some pings through the VPN tunnel to the gateway, which are returned successfully, and then disconnects. The 3 connections differ by the AES operations modes: AES Galois counter mode, GCM, AES counter mode, and AES cipher block chaining. In that order. Used for encrypting IKE, auth, and encapsulating security payload messages. Okay, so we have Galois counter mode with a 16 octet, AES counter mode, and AES cipher block chaining. We have a HMAC hash-based message authentication code, secure hashing algorithm 256 to 128. If you see RFC 4868, that's just the request for comments document that governs the creation of this HMAC SHA. It's a little confusing. It's called request for comments, but it's just a document. And then we also have cipher block chaining. Same thing here. Request for comments. These are basically, I'll show you what these are real quick. RFC, what was it? .368, 3686 and 4868. This one governs using AES, so you can work through this and see we have AES block cipher. This is cipher block chaining with encapsulated security payload. So it's governing how that's being used in with IP security. Anyway, let's take a look at the packet capture. I'm getting down some rabbit holes here. We got to extract this. Okay, that should be extracted. There it is. Okay, great. All right. Okay, here we go. We have ISA-KIMP protocols. We have encapsulated security payloads, ISA-KIMP, encapsulated security payload. Okay, let's take a look again at that sample capture. Let's see what they say here. Number 1, 2, and 3. 3 times a VPN, pings through VPN tunnel. So we have a VPN client 131, VPN gateway 92, and the tunnel is 2550. Let's see if we can identify those. Okay, so we see 92, we see 131. Okay, and here we go. We have 131 and 92. So 131 to 92, 92 to 131. And I think that, I don't know if we see anything else, honestly. Okay, so I think there's 3 sets of packets here. Are there? No, it's just the one. Oh, and here we go. We have these we need to extract also. Let's extract those. Okay. We have a decryption table here. And security associations, ESP SAs. Okay. All right, so what we're doing here is we're looking at, we could find the actual keys being sent, I think. UDP encapsulation of IPsec packets. Internet Security Association Key Management Protocol, ISA-KIMP. That's That's how I say it. Some people say it a little differently. I think it makes sense to say it that way. CySA. So we're seeing that UDP packets are being encapsulated there. So all this traffic is being encapsulated by IP security. Okay, great. So that's a good example. I mean, this is an example of any type of malware, anything that's wrong. This is an example of just how this technology is working. So it's a good visualization for a lot of these key terms that we usually talk about: encapsulated security payload, CyberKimp, IP security, Galois counter mode. It's hard to conceptualize those sometimes unless you actually see them in action, and that's what these packet captures can really help you with. So this is useful just to see this technology in action and see these different connections made using this technology, using this encryption, cipher block chaining, Galois counter mode, and counter mode, CTR. And let's see if we can see a differentiation between these two, or between the different techniques used here. Let me make this a little longer. You see the encapsulation. And if you see where we're looking for the different encryption techniques, that's what I'm trying to find here. I don't want to dig too deep into this because we can analyze this for a long time. All right. All right, I think this is pretty helpful, though, just to look at these different types of packets. Now let's take a look at the other one I wanted to take a look at here. We did this. I had a couple open that I wanted to look at. Oh, yeah, Kerberos. Let's take a look at Kerberos traffic. So we're going to analyze packets from basically an encryption process with Kerberos. So this one is also encrypted. Let's extract that to the desktop here. And then what we're going to do is we're going to analyze those again in Wireshark. Okay, so here what we have a list, and we can already see just with this first packet. Let me expand this out. Yeah, protocol Kerberos 5. So we have source 12.2 to destination 3.1, and then a response from 3.1 to 12.2, 12.2 to 3.1, 3.1 to 12.2. Let's see if we have any other hosts connecting. Okay, so we have right here an AS request. And then we have a ticket granting service request, TGS request. So we have the AS request. We have an error. So the first authentication was not successful. So probably somebody trying to input a password and it didn't work. They put the wrong password in. Then we have on the authentication service request, authentication service reply. So this one was successful. Okay. And then we have ticket granting service request, ticket granting service reply, and then we have a series of those. Now, do we have the time here? 5:41. Let's just see, compare it. 5:41. Yeah, so these are all the same user here. Okay, so this user made a series of requests. Basically, they wanted to do single sign-on using Kerberos. First, they put their password in incorrectly, I think. And then they made another request to try and log on. And that was successful. well, I'd say log on loosely. They're doing single sign-on through Kerberos. So they're authenticating to the Kerberos server, and then the Kerberos is providing them with tickets to access all the other resources on the network that are all incorporated within Kerberos. So instead of the user having to log on to each resource individually, the user is using single sign-on enabled through Kerberos. Great. And then we have another user here. Same thing. Authentication service request. And we see that this is the time similar? Yeah, the time's very similar, but it's about a minute apart. Well, these are all a couple seconds apart. Well, they're spaced out probably within a minute or so. This one is a minute later at 5:42. I'm looking right here. 5:42. So that request authenticated to Kerberos, and then we have another reply there. And we have a third request here. And then we have a series of replies again. Let's just see what they say about this. Example of Kerberos traffic when two users log on to main from a Windows XP key tab file is included. Okay, so we have a key tab, which would be here. Let's not waste time and dive into that one. Let's stay. We can really get into these and start analyzing the contents of the packet for the keys themselves and transferring the encrypted data and things like that. It's not really what I want to do with the scope of this. I just want to show you examples of these different packets. You could really dive deep into these, and if you do incident response, that's a useful skill set to know. But I think we'll stop it here for now. But I hope that was pretty helpful. Great job with these packets. I hope that was really informative. So I got some questions. I'm going to answer your questions now. Jerry, I'm glad the videos have been helpful. Thanks so much. Good luck on your Network Plus exam. And Leon, yeah, you remember the I love you worm. And thank you very much for your service. You're in the military, so I'm glad this is helpful for you. Is Kerberos the same as Okta? Okta. What is Okta? We'll look up Okta. I'm not sure about Okta. So I'm going to say no, because I don't think, but I'm not sure what Okta is. Is that a... Okay, so I found Okta. This is Okta. So Okta is a example. They're a service provider that does single sign-on, essentially, and federation. So they would manage authentication services for a client. They're an example of a CASP, Cloud Access Security Broker, CASP, with a B. So Okta, I think, can use Kerberos, probably. Yeah, Okta is an IT service management company. So it's a great question to take a look at these, because you might think so. Okta, IT service management company. Okta basically enables single sign-on. So they would probably have their own technology that they use to enable that. That's a good question, but no, it would not be the same as Kerberos. Yeah, Mr. Roboto, Wireshark does have the ability to filter data. That's very good. So we can filter this by destination here. We can add a filter 1.12.2, for example, or we can do by protocol. Then we have to add some flags in here to enable that. So you'd have to, there's a whole syntax that you'd have to do, but you could filter it by the protocol here, by the destination, source, etc. And we can sort by these, sort by the time. That's normally how it's done a list by time, but you can sort by all of those. And if you have a mixed packet filter or mixed capture, that can be very helpful to look at. Your beginner studying for Security Plus. Well, if you want to pass your Security Plus, check out the links in the description. Go to cyberkrafttraining.com and sign up for my course. You're going to pass if you sign up for my course. But we have lots of free resources there too. So if you want some free resources, check out Ports and Protocol study sheet that I have in the description, or it's on cyberkrafttraining.com. And check out my videos. Do lots of videos on Security Plus, try and help you pass your exam. I recommend studying a lot for Security Plus. It's much more difficult now, especially with the 701 version, than it used to be. So it's really very difficult certification anymore. Older cybersecurity professionals will tell you it's easy. Back when I took it, it was very easy. But it's not the case so much anymore. Great question. All right, guys, that's going to wrap up the stream this morning. I got to get in some meetings and get the day going. But I appreciate you guys joining in. Thanks for all the questions. And thanks so much. Thanks so much.